Okay, green 9. So the point on this one is that we're actually going to do something a lot like we did in the previous problem. We're going to parameterize this thing, and the hint, in fact, gives a nice point of view on how to parameterize this ellipse. So, for example, note that if you have an ellipse like so, right, and let's say that that is A and this is B, that is a stretched out version of the unit circle. Here's the unit circle, where that's 1 and that's 1. So in fact, I claim that this ellipse is what you get when you take that unit circle and you stretch it by a factor of A in the x direction, and you stretch it by a factor of B in the y direction. Does that seem reasonable? So the way I do that is, well, for the unit circle, I can parameterize that with x equals cosine t and y equals sine t. So for the ellipse, I'm going to stretch by a factor of a in the x direction by, well, multiplying this by a. Now, if you don't like that, again, you can say, well, in this equation, I can replace x with x over a. And that's a stretch in the, and of course, then the a comes up here. So ultimately, x equals a cosine t, y equals b sine t. And once you have the parameterization, again, the way you're going to compute the area is integral of x dy. And here's your x, here's your y. So you can compute y prime. Very, very similar calculation to number 8. Is that cool?
Yeah.
How about everybody else? Is everybody happy? Alrighty, stop this.